Welcome everyone to this lecture on supervised machine learning algorithm using OR. This lecture is divided into two parts. In the first part of this lecture, I will discuss the procedure of supervised machine learning algorithm, and then a Motor Trend US magazine data will be analyzed with R. Let's take a look at general supervised machine learning. So this is the general procedure for supervised machine learning. We have a data set, and then we can split this data set into training data set and testing data set. So typically we split 75% training dataset and 25% testing data. To use a dataset in machine learning, the dataset is always split into training and testing data. And this training dataset will be used to train the model, while this testing dataset that will be used to test the accuracy of the model. So based on the training data set, we produce this model, and the accuracy of this model will be determined based on the testing data set. Uh, all right, let's open up the RStudio and analyze the supervised learning method. First of all, load the required packages. Uh, So I can use this function to clear the workspace environment, and then we can use library mass, support functions and dataset, and then you can install this package or part, and this package is used for building classification and regression trees. Specifically, we can use this package for decision tree, and then you can install another package that is for random forest. So you can install this package and install the library. The first step in the supervised machine learning method, you can import the relevant dataset. Here we are using empty cars dataset, so you can import the dataset using read.csv function. And if the dataset is not available, then you can import the dataset using the data function command. To find empty cars dataset, we use the data function in our console to pull up a comprehensive list of dataset that exist in the background of the RStudio environment. So you can use this command if the dataset is not available in your computer. This is the alternative function to import empty cars dataset. And we can use head function to view the dataset. Okay, then we can split the dataset into training and testing dataset. So you can choose the sample using sample function, and here I'm using 75% for the training dataset and 25% for the testing dataset. So you can split training and testing dataset according to the situation, and maybe some people they prefer to split the dataset into 80% as a training dataset and 20% as a testing dataset. It depends on the situation. And then we have two types of the dataset. The first is training dataset, and the second is testing dataset from the empty cars dataset based on this indicator IND. And in this tutorial, I will use three models: linear regression, decision tree, and random forest. So first of all, we fit the linear regression model, and a, a quick and brief overview about linear regression model is that linear regression is used to identify the relationship between a dependent variable and one or more independent variables, and is normally used to make predictions about future outcomes. This is just a basic overview about linear regression model. So we can fit the linear regression model using LM function. So here we have dependent variable MPG and three independent variables, and we fit the linear regression model based on the training data, which is 75% of the total data set. And then we can print the summary of the linear regression model. And then the second step within the linear regression model is to predict the model based on the testing data set. And this testing data set, that is 25% of the total data set. So we predict the model, linear regression model, based on the testing data set. And the last step within the linear regression model is to evaluate the performance of our model. So to measure the performance of any model, we can use different measures, and here you can use mean square error, mean absolute error, and then root mean square error. So based on the error that we calculated from the linear regression model, is the testing data minus predictions of the linear regression model. So this is a standard residual. Dependent variable minus fitted value. Next, we can fit the decision tree. And regarding decision trees are type of the supervised machine learning where the data is continuously split according to certain parameter. The tree can be explained by two objects, namely decision nodes and leaves. The leaves are the final outcomes, and the decision nodes are where the data is split. So this is a basic overview about decision tree. In this lecture, I will not cover what is decision tree in details with examples. So this is just a quick overview about decision tree. So we can fit a decision tree using R part function in R, where we have dependent variable MPG and three independent variables. So based on the training data set. And then we can print the summary of this model. And then the second step, we can calculate the predicted value using predict function in R, using the fitted model dt from here. And for the prediction, we can use testing data set. All right. The last step, we can calculate the root mean square error. This is this measure we can use to evaluate the performance of any model. So this is the root mean square error, that is based on the dependent variable and the prediction variable. And the last step, we can calculate random forest. We can fit random forest, and random forest is another flexible supervised machine learning algorithm. And this random forest algorithm is used for both classifications and regression purposes. The forest references a collection of uncorrelated decision trees which are then merged together to reduce variance and create more accurate data predictions. So this random forest we can calculate based on the random forest function from the random forest package. And here again we have one dependent variable, which is mpg, and three independent variables. So we fit the random forest based on the training dataset, that is 75% of the total dataset. And then we can print the summary statistics if you wish, otherwise you can skip this step. Okay, then the second step within the random forest is to predict uh, the model based on the testing dataset, that is 25% of the total dataset. And then we can calculate root mean square error to evaluate the performance of this model. So based on the dependent variable and the predicted variable. All right, then we can print the root mean square error for each model. Here root mean square error for the linear regression model, and then we have root mean square error for the decision tree, and then RMSE for random forest. So in conclusion, the root mean square error is used to evaluate the accuracy of each model. Lower root mean square error values indicate a better fit. In general, it is recommended to try out a few different algorithms and see which one works best for a specific model. All right, let's run this program, and then we will see the results of the linear regression model and the decision tree and the random forest. Then we will select the best model based on the RMSE. So let's run the uh, program. Here we have output of this program. We can see that this is the RMSE of the linear regression model 2.367175, and this is the RMSE of the decision trees, and this is the RMSE of the random forest. So if we compare these three models, so we can say that lower RMSE values indicate a better fit. So we can see that 2.367175, this value is less than as compared to these two values. So based on the RMSE, we can say performing well as compared to other models. So we recommend linear regression model based on RMSE. All right, let's summarize this lecture. First of all, you can import all the required packages and the dataset. In the second step, you can split the data into training and testing. Normally, we split 80% training and 20% testing sets. Third step, fit the machine learning models. We fit in this lecture linear regression model, decision tree, and random forest. And then make the prediction based on the testing dataset. The last step, evaluate the performance of the models using performance criteria and select the best model. So this is the procedure for supervised machine learning methods. Thank you for taking the interest in this lecture.